Coming live from the house where we haven't left, haven't done anything, haven't gone anywhere. And hopefully you're doing the same so that we can go back at school soon. Because I know I'm ready to go back. But last night or over the weekend, you guys watched the video on what makes independent and dependent events. And real quick, hey Jose. Real quick, remember that independent means that one is not affecting the other, if so in probability. So the probability of one thing happening will not affect the probability of something else. Good afternoon, Tiffany. And then dependent means that in some way, shape, or form, the probability of one is going to somehow affect the probability of the other. Okay, so that's kind of your definitions there. And then there's a little formula that we could use to go ahead and test those things. So let's just jump right in and see how we did with it. So the way that the formula worked, was basically what you need to do is you need to take the probability that both of them will happen, or the intersection. So in this case, it says the month of March that has 31 days in it. In the New York, March has days when it snows, days when it rains, and days when it will do both. For those that were up early enough this morning, which is probably not many of you, there was about 5 minutes here where it was flurrying and raining, which is odd because tomorrow is going to be almost 60 degrees. Well, then this breaks down into here's your Venn diagram. So they're saying that in the month of March, 3 days, it is only going to snow. 8 days, it is only going to rain. And 5 days, it's going to do both. So if I was going to write that, here it is, snow and rain. Now, you should start making TikToks. One thing at a time here, Jose. Snow and rain. So now if you want to figure out if these events are independent or dependent, all you do is take the probability that it is going to snow and multiply it by the probability that it is going to rain. If those two answers are equal, then we would say, yep, the two events are independent, where what we were saying before, that snowing will not affect the raining. And if they are not equal to each other, then they're going to be dependent, and that means that they are affecting each other in some way, shape, or form. So here it is, the probability that's going to snow and rain. So remember, it's a fraction. What I want will go on top, and the total gets the bottom. Now, in this case, they told it to me here that the sample space had 31 days in it, so it's going to be 5 over 31. Now, probability that is going, why did I write 53? See, now you're all messing me up. You're getting married. Hopefully nobody will be there because everyone will be in quarantine. No offense. Okay, so 5 over 31. The probability that is going to snow, there were 3 of those out of the total of 31. The probability that is going to rain, there were 8 of them out of 31. And you nice and carefully go ahead and throw that into your calculator. Here is going to be 0.16, and here is going to be 0.11. So these two are not equal to each other, so we would say they are not independent, or that they are dependent, and here it is me justifying my response. Okay, so that's kind of a rundown on what you looked at over the weekend, hopefully. So here I'll go through the homework. Okay, so question 1. A coin is flipped and lands on heads. The coin is flipped a second time and it lands on its head again. Is the probability of it landing on heads the second time dependent on it landing on heads the first? Okay, so you're basically going to go ahead, flip a coin twice. Does doing it the first time have anything to do with flipping it the second time? And as Tiffany is screaming from her computer, she is saying that the two are dependent. Oh, you're probably on the last one. Independent on this one. Okay, and why is that? Because flipping a heads on the first try will not affect flipping it heads a second time. So we're going to say that these ones are independent. Okay. So there you go there. Second one. So now here's where we're going to look at this. An elementary class consists of 8 boys and 10 girls. A child is chosen at random, and it is a girl. A second child is randomly chosen again from the remaining children, and it is a boy. Was the probability of choosing the boy dependent on choosing a girl first? Explain. So if the easiest way to explain it is for me to show it to you. So in this class here, if I'm looking at it, there are 8 boys and 10 girls. So there are a total of 18 students. And they said that they were going to pick a girl first. So if they picked a girl first, there's a 10 in 18 chance that that's going to happen. Now, if we go ahead and now we're going to pick a second child, we already picked a girl, so now the probability here is going to be 17, or the total here is going to be 17 because there's a girl missing, and there are 8 boys. So right there, okay, these probabilities just change. The probability changed because our totals change. So it's yes, okay, because choosing the girl changes our probability or changes the total amount of students that we get to choose from. Okay. Number 2, a newspaper did a survey of adults and found 54% of the population as a whole favored stricter gun control laws. They broke down the results along gender lines and found that 65% of women favored stricter laws, while only 44% of men favored them. If a person was selected at random, are the events of being a woman and being in favor of stricter gun control laws dependent or independent? And explain. Okay, so now here we're going to say dependent, and it's because of what they just said. Because the probabilities would have to be the same for men and women. And that was around like 54%. Okay, so because they are breaking down to different percents, then that means that they are going to be dependent. Okay, number 3. I don't know, maybe they're all still sleeping, Bergman. Okay, the 8th spinner is back. If the spinner is spun once and the outcome is noted, answer the following questions. So let S be the event of getting a perfect square, 1 or 4. What is the probability of getting a perfect square? Okay, so the probability of getting a perfect square. Okay, there are a total of 8 to choose from. How many of them are perfect squares? Okay. 1 was a perfect square and 4 is a perfect square. So there are 2 in 8 or 1 in 4 chances of getting a perfect square. Okay. B. Let E be the event of getting an even. What is the probability of perfect square given you got an even? Okay. Probability of S given E. Are these 2 events independent? So S given E. So remember, this is what's going to go on the bottom. S and E is what's going to go on the top. Okay. So if we look at this one, and the probability of getting an even, 2, 4, 6, and 8, there are 4. Okay. Probability of getting a perfect square and an even, so think of 2, 4, 6, and 8. How many of these are perfect squares? Well, there's just 1. So it's a 1 in 4 chance. So are these 2 events independent? Okay, are these 2 events independent? Well, look at our last one. The probability of getting a perfect square was 1 in 4. The probability of getting a perfect square given that you're even is 1 in 4. So remember what we said. If our 2 probabilities are equal, then the 2 events are independent. Okay, independent. Okay, so the probability of S is the same as the probability of S given E. Okay, both 1 in 4. Okay, and now going down to here. Okay, similar question. Let M be the event of getting a multiple of 4. What is the probability of getting a perfect square given that you got a multiple of 4? Probability of S given M. Are these 2 events independent? S given M. So our bottom number are all of our multiples of 4, okay, which would be 4 and 8 only, which would be 2. And of 4 and 8, which one of those are perfect squares? And that would just be 4. So it's a 1 in 2, or 1/2 probability. So now is 1/2 the same as getting the perfect square of 1/4? And we would say no. Okay, they are not independent. The probability of S is not equal to S given N. Okay. Okay, this one just kind of goes back to our formula, probability of A and B. If we're going to prove independent, remember we just multiply our two probabilities. And this one was a multiple choice question, choice 2. Okay, going to 5. There's a 34% chance that a person picked at random from the adult population is regular smoker of cigarettes, and an 18% chance that a person picked as an emphysema. If the person of the adult population that are both regular smokers and suffer from emphysema is 14%, is being a smoker independent from having emphysema. Okay, so independent, smoker, and emphysema. Probability of smoker, probability of smoker and emphysema. So I would have to figure out probability of the people that smoke times the probability that people have emphysema and see if these two are the same. So if we go back to here, 34% chance that a person's a smoker. So remember, convert that to a decimal, divide it by 100. And then emphysema had a 0.18%. And then they told me that smokers and emphysema, there was a 14% chance. So then I would take the 14% chance and multiply it by 0.34 times 0.18, and no, it is not 0.0612. So they are not independent. Sorry to hear that, Jose. All right, going to 6. Okay. So now we're going to go back to reading those tables again. Okay, so the first one, A, showed that the event of having green eyes and red hair are dependent. So probability of green eyes and red hair. So if I'm going to do that, first I better figure out the probability of green eyes, multiply it by my probability of red hair. So eye color is green. There you are, 0.25. We're red hair. That is 0.18. And the green eyes and red hair is that intersection point is 0.15. Okay, so now multiply them. 0.25 times 0.18 is 0.045. These are not equal, so they are dependent. Okay. B, many of the hair colors have dependence on eye color. Does having blonde hair have a dependence on having brown eyes? Show the analysis that leads to the decision. Okay, so then here we go. Okay, so we have brown hair and blue eyes. Probability of brown hair times the probability of blue eyes. So let's get rid of this last one. Let's see, blonde hair. Okay, that's 0.37. Okay, blue eyes, 0.40. Blonde hair, blue eyes, blue eyes. Brown eyes, oh man. Okay, brown eyes, 0.35. Where did they intersect? At 0.13. So multiply your 0.37 times your 0.35. That's 0.1295. Remember, we like to go to 2 decimal places. So 0.13 is indeed equal to 0.13. So they are independent. And there's your lesson for today. Bergman, look, we only have 5 people left. Hopefully you watched this. Hopefully you get to the end here. You guys have a lot of work that you're going to need to be doing this week. One is getting on Delta Math and getting the assignment that we have on there done. 2, getting onto cimath.com. There's a couple things on there that you need to complete. And 3, there will only be one more video left this week, and that's tomorrow's final lesson. After that, you're going to have 2 days. There's going to be a review that you're going to do. On Thursday, we're going to post the answers to the review with a video kind of explaining each question. If you have any other questions, we'll try to maybe post a live, just like an extra help, nothing formal. You come with any questions you have, and then over the weekend, you're going to have a test to complete. Tonight, I'm going to do at 8 o'clock a live stream on how to sign up for Google Classroom. I am not, Ms. Holden is not doing we have a Google Classroom, but it just says go to cimath.com. We already have everything we want and set up there, but I'm sure there's a lot of your other teachers that are putting assignments on there. So if anybody has any questions or need to know how to set up their Google Classroom, we'll be able to do that tonight. All right, have a great day. Stay dry, and